Hello everybody. This assignment is called a very simple geologic timeline. And what we have here, the colored numbers and MYA here, that stands for millions of years ago. And 1,000 million years is a billion years. So 4,600 million years ago, that's 4.6 billion years ago. And whereas 0.2 million years ago is going to be about 200,000 years ago. But we're working in the same units here just so it has some continuity. And for each time period that's listed here, you're going to write down a short explanation of what happened at that time during Earth's history. And I'm going to share some information about the history of the Earth. The Earth is 4.6 billion years old. But how big is a million? How big is a billion? Well, both are immense numbers, but a billion is way, way bigger than a million. A billion is 1,000 times 1 million. So we'll see if we can illustrate that point with a couple of examples. Money. If you had $1 million in $100 bills, all that money would fit inside of a backpack. But if you had $1 billion, all in the same denomination, $100 bills, you would need a very large 18-wheeler semi-truck to carry that money away. Another way to think about it is time. Your million-second birthday happened when you were 11 days old, and every 11 days another million seconds passes by. But your billion-second birthday hasn't happened yet. It'll happen when you're 31 years old. So a billion seconds takes a lot longer than a million seconds. So the unit we're working on is about geologic time, which means very, very long spans of time. Scientists use rocks and fossils to figure out what happened throughout Earth's history of 4.6 billion years. That's billion with a B. So a very, very long time. That's the amount of time that has passed since our solar system's formation. So we've got a bunch of earmarks on the geologic record, and I want you to write down what happened at each of these periods. So start with 4.6 billion years ago, or listed on your slide as 4,600 million years ago. That's when the Earth formed. And we have a picture here of solar nebula theory. If you recall from the astronomy unit, that's how all solar systems form. And then a little while later, 4.5 billion years ago, we have the formation of the moon. And scientists believed that happened when another small planet collided with Earth, knocking a chunk out of Earth, and that chunk became captured in Earth's gravity and now orbits the Earth, and we know it as the moon. 4 billion years ago, we have the first simple organisms appearing on the fossil record. So just bacteria, stuff you'd have to see under a microscope, but they were there, life nonetheless. You can pause this video anytime you need to if you need more time to flip back and forth and keep writing this stuff down. 3.4 billion years ago, or 3,400 million years, same amount of time there, we have the first photosynthetic organisms appearing in the fossil record. So prior to that, all organisms, all that bacteria was chemosynthetic, getting their energy from chemical bonds. But starting 3.4 billion years ago, we have the first organisms that could perform photosynthesis. And at first there weren't that many of them, but they were very, very successful. And over the course of about 1 billion years, they kind of took over the planet. And about 2.3 billion years ago, we have something called the Great Oxygenation Event. So we have these organisms, they're putting oxygen into the atmosphere, they're becoming more and more successful. At first their oxygen is bound up into minerals, but then there runs out of space in the rocks and minerals for the oxygen, and it starts being pumped into the atmosphere, and it grows and grows and grows. This is called the Great Oxygenation Event. And we're glad that oxygen's there now, but it was a big change at the time for the planet Earth. About 1.3 billion years ago, we have the first plants showing up. This is still underwater, so like seagrasses and seaweeds. And then 670 million years ago, so quite a while later, we have the first animals evolving. So multicellular organisms, very, very small still, very simple organisms, but animals nonetheless. And then 541 million years ago, we have something called the Cambrian explosion, which is when multicellular life became widespread. All of a sudden, we have new kinds of organisms showing up left and right in the fossil records, larger organisms, lots of multicellular critters, lots of animals, lots of predators, more of like a full ecosystem taking shape all over the planet. And then, this is all in the ocean so far. It wasn't until 471 million years ago that the first plants appeared on land. So the Earth had been around for more than 4 billion years before any life came on land. And then 434 million years ago is the first mass extinction event, uh, possibly caused by mass glaciation, an ice age. And then we have 359 million years ago, the very first animals start to crawl out of the ocean onto land and live on the land. And then there's another extinction event, 354 million years ago, the late Devonian extinction. And these extinction events are when at least 75% of the organisms on Earth perish, never to return. And there have been 5 major extinctions thus far. 335 million years ago is when Pangaea split. Pangaea wasn't the first supercontinent, but it was the most recent supercontinent, and it's the supercontinent we talk about the most. 335 MYA, millions of years ago, Pangaea splits. And then 251 million years ago, we have another extinction event called the End Permian, and that's when the age of the dinosaurs began. 205 million years ago, the End Triassic extinction, yet another extinction event. These things are very important in geologic history. But the dinosaurs still reigned supreme until 65 million years ago, when we have something called the KT extinction, or the Cretaceous Tertiary Boundary extinction. The dinosaurs went extinct and the age of mammals began. 65 million years ever since then, mammals have been in charge. 35 million years ago, we have the Chesapeake Bay crater, which we learned about in an earlier unit. A giant meteor slams into Virginia. And then 2.8 million years ago, the earliest human ancestor. So in the course of Earth's entire geologic record, humans have been around for just the blink of an eye. And this isn't even Homo sapiens. This is the earliest relative in the fossil record. It wasn't until 0.2 million years ago, so 200,000 years ago, that the first Homo sapiens began roaming the Earth. So Homo sapiens, what we are, has only been around for 200,000 years. They say if all of Earth's history was 24 hours in a day, human history would be the last 30 seconds before midnight. So that's the last thing you have to write down. Just a couple of other things to illustrate how recent our history has been. 0.03 million years ago, we have the first cave paintings. That's 30,000 years ago. And 0.01 million years ago, we have the first human civilization, or the first record of human civilization 10,000 years ago. And then 5,000 years ago, which is 0.005 million years ago, the invention of the wheel. And then 0.0002 million years ago, the Industrial Revolution begins. That's 200 years ago. So as far as the Earth is concerned, that was yesterday. And then the invention of the computer, 70 years ago, 0.00007 million years ago. And that is my brief history of Earth. You can go back and catch anything that you missed by rewinding the video, and just fill out all of the times on your slide here.